welcome. So this is a continuation of the previous lecture where we are discussing about kernel data structures. So in the last lecture we have discussed about arrays, linked lists, different types of linked lists, stacks, queues, and binary tree, binary search tree, and balanced binary search tree. Okay. In this lecture, we will be discussing about some more data structures. So primarily we will be discussing about hash function and bitmap function. So let us try to understand what is a hash function. Hash function is a function, okay? So it is a function. This function, what it will take in the sense, it will take some value as the input. It will take some value as the input and it will provide some integer output, okay? It will take some value as an input. It's a function. It takes some value as an input and it will provide some integer output. Okay. And what this integer output represents, this integer output, refers to the which location it has to access. Okay. So let us assume that the memory contains uh, several locations. Okay. Sorry. So let us assume the memory contains several locations, something like this. Okay, I'll draw a little small because I want to draw something else. Okay, so these are the locations. Okay, so each location, as you know, it will have an address. Okay, so this hash function, so basically it is a function. So it takes some value as an input. So this function will take something as an input and it will provides some integer as the output. Okay, so whatever the output it provides, so it provides some output. This output will tell the operating system which location it has to access. So for example, these are different addresses. For example, if the output is some x, then it may access this location if x refers to this location. Or you can assume that these addresses were starting from uh, say 1000. Okay, say 1000 to 1100 locations. Okay, and if this address, if it refers to say 1020, okay, if the output is 1020, then it means that operating system should look at location 1020 and whatever the instruction at 1020th location it will execute. Okay, so why the operating system uses hash function? In the sense, operating system need not check location by location, what should I do. Rather, it can just call the hash function by passing a value, and whatever the output it comes, it will directly go to that location and it will execute that instruction. Okay, so this is the core purpose of hash function. But there is one disadvantage with hash function. The hash function may lead to a problem which is called as hash collision. The hash function may lead to a problem which is called as hash collision. What is meant by hash collision? Hash collision in the sense, sometimes two values may map to a same output location. Okay, so in that such a problem we call it as hash collision. Okay, say for example, for this hash function I am giving a value say 12 as input. When I give the value 12 as input, say it is producing an output 1024. Okay, 1024. So it means that operating system should go to the location 1024. Say if this is 1024, then it should go to the location 1024 and whatever is in 1024 it should execute. That is what the meaning is. Okay, but assume that now I am giving another input, say 15, for the hash function. That is, here the parameter I am passing is 15. Now for this 15 also, if it produces 1024, then such a scenario is called as hash collision. That is, for the input 12 also the hash function produces 1024 and for 15 also it is producing 1024. Now it means that for both the inputs the operating system is asked to execute the same instruction, which may not be the case. So in that case, what the operating system can do, this hash collision can be overcome by using some linked list here. So rather, instead of storing any instruction here, the operating system, what it will do in the sense, it will store a linked list here. Okay, so in this case, two values are matching to the same location, so it will maintain a linked list with two nodes. Okay, so maybe, and these two nodes will have some instruction. This will have one instruction, and this may have some other instruction. Okay, so the operating system may follow some mechanism, like what it will do in the sense, if for example, uh, if the input is 12, it may execute this instruction. If the input is 15, it may execute this instruction. Okay, okay, this is one mechanism to overcome hash collision. But if the collision is more, then obviously it will degrade the performance. So this is how a hash function works. That is, a hash function is an ordinary function which takes a value as an input and produces an output. The output, nothing but it refers to the memory location. So the operating system uses this to refer to to directly access a particular memory location and execute the instruction. But sometimes hash function may create a problem which is called as hash collision. That if two or more values refer to the same location, that is, if the two or more input to the hash function, if it gives the same output, then that problem we call as hash collision. If there is a hash collision, then the operating system can overcome hash collision by using linked list in that particular, by connecting a linked list to that particular location. But still, if the degree of collision is more, that is, if more collisions are created by the particular hash function, then the performance will degrade. Okay, and one another use of hash function is something called as hash map. Okay, this is another usage of hash function. So what is the hash map in the sense? In a hash map, you will be maintaining something called key and a value pair. So for every key will be mapped with a value. So the key will be the input and the value will be the output. That is, the hash function will take key as the input and it will create the value as an output. Okay, so the hash function, say I am calling it as hash function, which refers for hash function. So the hash function will take key as input. Okay, so this function will take key as input. So let me call key as k, and when you execute the hash function, it will provide the output. The output here we call it as value. Okay, the output is called as value. Okay, so this output is called as value. So this type of thing it is called as hash map. That is, the key will be mapped to a particular value originally. So whenever you give a particular key, the value will come out. Okay, so typical applications are connecting username with password. Say for example, the operating system is maintaining different users. So for every user, there will be a particular password. So operating system need not go and search the password from a memory or anything like that. It can rather maintain a hash function and it can map the username with the password. Okay, so so it should originally map every username. It should map with the respective password. Now, if a username is given to the particular hash function, it will automatically give the password as the output. Okay, so when the user logs in, the operating system will just give the username to the hash function, and it will get the password, and then it will check whether the whatever the password the user is giving, is it matching with that or not. So if it matches, the operating system will allow the user, otherwise it will not allow the user. So such a mapping a key to a particular value and using it for different applications is called as hash map. Okay. So that's it about hash function and hash map. And the next thing what we'll be discussing is bitmap. So bitmap is a very nice data structure which can be used to identify the status of different items or status of different resources. Okay, so basically it is a collection of binary strings. A bitmap is a collection of binary strings which can be used to represent the status of different items or different resources. Say for example, we are using a 8-bit bitmap. So this is, there are totally 8 bits. This is 0th bit, first bit, second bit, third bit, fourth bit, fifth bit, sixth bit, seventh bit. So 0 to 7 there are 8 bits. Okay. So this 0th bit refers to resource 0. First bit refers to resource 1. Second bit refers to resource 2. Like that, so on and so forth, up to the 7th bit refers to resource 7. So each of these resource may refer to some physical or logical resource. This may refer to memory, this may refer to CPU, this may refer to printer, this may refer to scanner, this may refer to some file, this may refer to some process, whatever it may be. Okay. So whether it is, so this is a binary string. So each of this is a binary value. So it can be either 0 or 1. So let us assume if it is 0, then it is currently being used by some process. This resource is not free. It is being used. Okay. And let us assume if it is 1, it is free. Okay? Or other way also you can think. If it is 1, you can say it is being used, and 0 it is free. But here let us assume that 0 is the resource is being used. 1 means the resource is free. So with this, the operating system can identify which resources are free and which resources are being used by some other process. So here you can say the resource R2, R4, the resource R6 and R7. These resources are free. Resources 2, 4, 6 and 7 are free. Whereas resource 5, resource 3, resource 1 and resource 0, these resources are being utilized by some particular process or whatever it may be. Okay. So this is also one data structure. So bitmap. So this type of data structure is called as bitmap. So basically bitmap is a data structure which maintains a collection of n binary strings, and each of these binary bits represent whether a resource is being used or it is not being used. Okay. And so you can see various data structures that is used by the Linux operating system in these header files. Okay. If you have a Linux system, you can check these header files. Okay. So this is the path. You can check these header files, how these data structures were implemented, because Linux is a open source operating system. Okay. Fine. Let us stop here. So that's it about kernel data structures. So under kernel data structures, we have discussed different data structures like arrays, linked list, different types of linked list. Then we have discussed about stacks, queues, and we have discussed about trees, binary tree, binary search trees. Okay, balanced binary search tree. Then we have discussed hash function, hash map, and bitmap. Okay, so we have discussed just a brief introduction to all these data structures. Okay, fine. Thank you. We'll stop here.